In section 9.3, we're going to discuss significance tests about population means. The learning objectives for this section include considering for population means the steps of significance tests and an example, the p-values for different alternative hypotheses, the two-sided test and confidence interval results agree, what happens when the population does not satisfy the normality assumption, and regardless of robustness, we need to look at the data. Our assumptions for the population mean are that the variable is quantitative, the data are randomized, and the population is normal or at least approximately normal, particularly important whenever we have a small sample size or a one-sided test. Once we have our assumptions, our hypotheses for the mean, the null hypothesis is always going to be that the mean is equal to a particular value, and then the alternative hypothesis is going to be that the mean is either greater than, less than, or not equal to that same particular value. Once we have our assumptions and our hypothesis, we want to compute the test statistic. In this case, our test statistic is t, and this is the formula that we use to compute the test statistic. Or we can more efficiently compute both the test statistic and the p-value using our TI calculators. Step 4 is to compute the p-value, and the p-value will be used to assess the evidence against the null. And then we will use the p-value and compare it to our alpha value, our significance value. If p is less than or equal to alpha, we will reject the null hypothesis. If p is greater than alpha, we will not reject the null hypothesis. And then we should summarize and interpret in context of the original alternative hypothesis exactly what we conclude. Statistically significant results aren't always practical results. For example, let's suppose that we have a diet that's designed to produce weight gain in anorexic girls, and we want to test to see if it's actually making these girls gain some weight. Our p-value on the test is 0.018, and that is certainly less than 0.05. So for that reason, we would reject the null hypothesis, and we would say, yes, this is effective in helping these girls gain weight. The weight gain is statistically significant, but is the weight gain practically significant? Well, if we do a 95% confidence interval on this particular diet, we'll find that the weight gain is between 0.2 pounds and 5.8 pounds, so this may not be considered a practically significant amount of weight to gain in this particular scenario. As with proportions, we have three options when we're considering alternative hypothesis for the mean. We have right-tailed test, left-tailed test, and two-tailed test. And as with proportions, I try to remember that the less than that starts with L, left also starts with L. These two go together, and then the other, the right-tailed, is for greater than, and of course the not equal will mean that you'll have two separate tails. It turns out that the two-sided test and confidence interval results will always agree. For example, if we have a test statistic that is so extreme that it's going to produce a very small p-value, then that means we're going to reject the hypothesized mean. But also, if we look at the confidence interval of this test statistic, a 95% confidence interval won't contain our hypothesized mean. So in that way, the results agree. Conversely, if we have a p-value that's not so much extreme, then that p-value is not going to end up being rejected, so we won't reject our hypothesized mean, and the confidence interval there will contain our hypothesized mean. Recall that one of our assumptions for significance test about means was that our population was normally distributed, but what happens if our population doesn't satisfy that normality assumption? Well, it's okay if we have a large sample size, because remember back when we talked about the central limit theorem, if we have a very large sample size, our sampling distribution of the sample means is normally distributed anyway, regardless of the population distribution. So we'll be okay as long as we have a large sample size. Will also be okay as long as the test is two-sided in most cases. It works well even for small samples. But what if we have a one-sided test where we have a small sample size, and particularly when the data is highly skewed as it is here? Well, it just doesn't work well. Significance tests should not be performed when we have one-sided tests with small sample size and highly skewed data. And really, regardless of the sample size, whenever you have very severely skewed data or outliers, you should seriously consider the accuracy of your test because you could be getting something that's extremely misleading.